So continuing on here, they're going to do more polynomial long division. This time our exponents maybe get a little bit bigger, but not a whole lot different than what we just did. If I have 6x minus 2 and I'm going to divide it into 24x to the third plus 4x squared plus 14x plus 3. What times 6x will give us 24x to the third? 4x squared. So we're going to put 4x squared on top. 4x squared times 6x is 24x cubed. 4x squared times a negative 2 is a negative 8x squared. We then have to subtract, so we change our signs. So that one becomes positive 8x squared. Cancel out our 24x cubes. 4x squared plus 8x squared would give me 12x squared. And you can just bring down the rest of that and then repeat the process. So what times 6x gives us 12x squared? 2x. So we put a plus 2x up on top. 2x times 6x is 12x squared. 2x times a minus 2 is a minus 4x. But then we subtract, so we change our signs. 12x squareds cancel out. 14 plus 4 would give me 18x plus 3. So, what times 6x gives us 18x?
3.
Positive 3. 3 times 6x is 18x. 3 times a minus 2 is a minus 6. We then have to subtract, so we change our signs, and our remainder would be 9. So our quotient, 4x squared plus 2x plus 3, our remainder, 9. And again, if you really wanted to, you could take your 6x minus 2 times your quotient and add your remainder, and it should work out to what you started with. Second one there says we're going to take 5x minus 1 into 15x to the third plus 17x squared plus 11x plus 6. So what times 5x would give you 15x to the third? 3x squared. We would then get 15x cubed minus 3x squared. But then we have to subtract. So we change our signs, and we're going to bring down 20x squared plus our 11x plus 6. So what times 5x gives you 20x squared? Positive 4x. Multiplying that out, we would get 20x squared minus 4x. But then we have to subtract. So we change our signs and we bring down 15x and our plus 6. So what times 5x gives us 15x? 3 plus 3 up there. 3 times 5x is 15x. 3 times a minus 1 is a minus 3. But then we have to subtract. So we change our signs and our remainder, 9. Almost like the remainders of 9 today. So 3x squared plus 4x plus 3 is our quotient. 9 is our remainder. Third one there, we are going to take 5x squared plus 6x and divide it into 15x to the third plus 28x squared plus 7x minus 8. So what times 5x squared would give you 15x to the third?
3x.
3x. So we would get 15x to the third, and 3x times 6x would be 18x squared. We then have to remember to subtract, so we're going to bring down an x squared plus our 7x minus the 8. So what times 5x squared gives you 10x squared? 2, positive 2. So 2 times 5x squared is 10x squared. 2 times a positive 6 is a plus 12x. We then have to subtract. So we're going to bring down negative 5x minus 8. Now, since this exponent is higher than this exponent, I'm done. That all there is going to be my remainder. So my quotient is 3x plus 2. My remainder, negative 5x minus 8. And again, for fun, if we wanted to check that, we would take 5x squared plus 6x times 3x plus 2, and then we'd add our remainder, which is negative 5 minus 8. And so if I FOILed that out, I get 15x to the third plus 10x squared plus 18x squared plus 12x minus 5x and minus 8. Combining my like terms, 15x to the third, 10x squared plus 18x squared is 28x squared. 12x minus 5x is 7x minus 8. Hey, look at that. I got the same thing I started with. Checks out. Polynomial long division problem type 3. Now they're going to start rearranging your polynomial so that it's not in best form, and you're going to want to rearrange it and put it in best form. If they leave out a term, we're going to put a 0 in its spot so that everything will line up all nice and neat. This time they're going to have our answer in a different form. Your quotient is going to go in front. Your remainder goes on top of the divisor, like you would have when you did long division back in 3rd grade. So I'm going to take 3x squared minus 1. I'm going to divide it into 3x to the 4th minus 9x cubed. Then I'm going to put the plus 11x squared. Then I'm going to put plus 0x just as a placeholder so that everything lines up nice. Then I'm going to put the minus 4 so that you have your exponents in descending order 4, 3, 2, 1, 0. And I can do my long division. So 3x squared, what times 3x squared gives me 3x to the 4th? Just an x squared. So 3x squared times x squared is 3x to the 4th. X squared times negative 1 is a negative x squared. I'm going to line that up underneath my x squared column so my like terms are all nice and lined up. I'm then going to subtract. So I'm going to change my signs so I can cancel out my leading term. So I'm going to bring down the negative 9x to the 3rd plus 12x squared plus my 0x's minus 4. And then I'm going to say, what times 3x squared gives me negative 9x to the 3rd? Negative 3x. So negative 3x times 3x squared is negative 9x to the 3rd. Negative 3x times negative 1 is a positive 3x. I'm going to put that underneath my x column. And then I'm going to subtract. So I'm changing my signs so I can cancel out my leading term. So I get 12x squared minus 3x minus 4. And then I get to repeat it one more time. So what times 3x squared gives me 12x squared? Positive 4. So 4 times 3x squared is 12x squared. 4 times negative 1 is a minus 4. I'm going to subtract, so I change my signs. And my remainder is going to be negative 3x, because that cancels and that happens to cancel. So the x squared minus 3x plus 4 goes here. The negative 3x will go on top of that fraction, since that's your remainder. Number 5 then, I have 5x squared plus 3, and how should I write my polynomial underneath my division there? Negative 10x to the 4th is my first term. Minus 20x cubed. It's 9x squared. Minus 13x. And plus 16. That time they didn't leave out any terms, we just had to rearrange them and get them in the best order. So what times 5x squared gives us negative 10x to the 4th? Negative 2x squared. So we're going to get a minus 10x to the 4th, and then we're going to get a minus 6x squared, so we want to line that up in the right column. We need to subtract, so we change our signs. And we're going to bring down negative 20x to the 3rd plus 15x squared minus 13x plus 16. And so what times 5x squared gives us negative 20x to the 3rd? Negative 4x. So we're going to get a negative 20x to the 3rd, and then we're going to get a negative 12x. Line that underneath our x column. We're going to subtract, so we change our signs. So this becomes positive, and that becomes positive. Cancels out our leading term. So we have 15x squared negative x plus 16 then. So what times 5x squared gives you 15x squared? 3. Positive 3. So 3 times 5x squared is 15x squared. 3 times 3 is a positive 9. But then we have to subtract, so we change our signs. And our remainder is going to be negative x plus 7. So the negative 2x squared minus 4x plus 3 will go there. The negative x plus 7 will go on top of our fraction. Number 6, we have negative 3x squared plus 2x plus 3, and we're going to divide that into, which should go underneath our division sign.
Negative 6 to the 4th plus 4x to the 3rd plus 0x squared plus 11x.
Exactly. So what times negative 3x squared gives us negative 6x to the 4th? 2x squared. So we get negative 6x to the 4th, positive 4x to the 3rd, and a positive 6x squared. But then we have to subtract, so we change all our signs. That cancels, and so we have negative 6x squared plus 11x minus 3. So what times negative 3x squared gives us negative 6x squared? Positive 2. So we get negative 6x squared. 2 times 2x is plus 4x. 2 times 3 is plus 6. And so when we subtract and change all our signs, we're going to bring down 7x minus 9. And since this exponent here is higher than this exponent here, that tells us that's our remainder. So 2x squared plus 2 and 7x minus 9. And again, if you were really bored, you could take that times that and add your remainder, and you should get what you started with. Seven, 8, and 9 are synthetic division. Synthetic division works when you have nothing, or actually it's a 1, in front of your coefficient of your x. So these are like the very first long division problem type ones we did, and we could do these by long division, but synthetic division is kind of a shortcut. They've already set up your synthetic division table for you, which was really nice of them because in the book you'd have to do it yourself. What they did here is, first of all, they set this equal to 0. If x minus 4 equals 0, you have a positive 4 on the outside. Then they use the coefficients of each of your terms. If they skip any, there'd be a 0. But we had a negative 1x cubed, a 3x squared, a 6x, and a minus 8. In the event you have to set that up on your own sometime. On Alex, they do it for you. Synthetic division, what they're first going to do is just drop down that first one. Almost fits in my box, so that's going to stay negative 1. Then what we're going to do is we're going to multiply, put the answer up here, and add, and just keep going through there. So 4 times negative 1 is negative 4. Our 3 plus our negative 4 is a negative 1 in that bottom box then. 4 times negative 1 again is negative 4. 6 plus negative 4 is 2. 4 times 2 is 8. Negative 8 plus 8 is 0. So drop the first number and then multiply and add, multiply and add, multiply and add. So what happens is the end number is your remainder. That's going to go in the little box above the fraction. The numbers in front of that are the coefficients to your answer 1 degree lower than your original polynomial. So since this was a 3rd degree polynomial, we're going to have a squared. So I'm going to have a negative 1x squared, which would be negative x squared, minus an x, plus a 2, and then of course our remainder is 0. So that's a lot quicker probably than doing long division once you get the hang of doing synthetic division. So number 8. First thing I'm going to do, drop my 3 down, put that in the first box. So negative 2 times 3 would be negative 6 plus the 7 above that is 1. Negative 2 times 1, negative 2 plus the 0 above that, negative 2. Negative 2 times negative 2, positive 4. 4 plus the negative 1 above that, 3. So the 3 is your remainder. These are your coefficients, 1 degree less than the original one, which was a cube, so we get squared. So we're going to get 3x squared plus 1x to the first minus our 2 with our remainder of 3. Number 9 then. First thing we're going to do, drop my 2. In the next box on the top row, I'm going to have negative 6. Then we're going to bring down 4. Then we're going to get negative 12 and bring down negative 3. Then we're going to have 9 and bring down 2. And then we're going to have negative 6 and bring down negative 1. So our quotient would be 2x to the third
plus 4x
plus
squared
4x squared
minus 3x
minus 3x
plus 2.
plus 2 with the remainder of negative 1. It almost looks like a negative 1 there. And the last thing is the factor theorem. The factor theorem says that if x plus 2 is a factor, then if I set that equal to 0 and put that number into my polynomial expression, I would get an answer of 0. So if x plus 2 is a factor, we're going to do p of negative 2, and they're going to make you put that into the little parentheses in the answer box. Just set that equal to 0, put a negative 2 in there. Then what we're going to do is put negative 2 into our polynomial. So 2 times negative 2 cubed plus 3 times negative 2 squared minus 3 times negative 2 minus 2. When we solve that, if we get an answer of 0, it is a factor. If we get any other number, it is not a factor. So we got to solve that. Doing our exponents first. Negative 2 cubed is
Negative 8.
negative 8 times the 2 in front,
Negative 16.
negative 16. Negative 2 squared,
4.
positive 4. 4 times the 3 in front, 12. Negative 3 times negative 2, plus 6 and minus 2. So 16 minus 12 plus 6 minus 2, I would probably do these two together and those two together, just because that makes it easy. If I do that, I get 0. So they're going to have you put a 0 in the blank. Is it a factor? Yes, it is, because we did get an answer of 0. So, number 11, we want to know if x minus 3 is a factor. That means we're going to evaluate p of 3. So 2 times 3 cubed minus 6 times 3 squared minus 9. So 3 cubed is 27. 27 times 2, 54. 3 squared is 9. 9 times negative 6, negative 54 minus 9. Well, that makes that easy. Our 54s cancel out, so we just get minus 9. Is x minus 3 a factor? No. We didn't get a 0, so it is not a factor. And the last thing, or last one in chapter 3 here, if I want to figure out if x plus 1 is a factor, I'm going to evaluate p of negative 1. So I'm going to have minus my negative 1 to the 4th minus my negative 1 to the 3rd plus 3 times negative 1 plus 8. So negative 1 to the 4th is 1, but there's a negative in front, so we're going to make that negative 1. Negative 1 to the 3rd is negative 1 times negative 1 makes that a plus 1. 3 times negative 1. So when we do our adding and subtracting, we get a 5, right? Is it a factor? No, it is not a factor because we didn't get 0.